Welcome to my vitamin. Today we are going to do an extremely difficult integral this time. And this time we cannot use the substitution, and we can write this 4x squared as parentheses 2x squared and then use a substitution. That would be too easy. This time we are going to do this integral by using the Freyman technique. Look at this integral. Freyman technique. The integral of ln(x) over 1 plus 4x squared going from 0 to infinity. Look at this integral. The integral of ln(x) over 1 plus 4x squared going from 0 to infinity. So, look at the constant 4. I would like to put a constant I of a is equal to ln(x) over 1 plus ax squared dx. So, can we differentiate both sides now? No, because I think you can, but don't do that. Because after differentiating both sides, you get consider that ln(x). ln(x) is just a constant in the a row, so over you're going to differentiate this 1 over 1 plus ax squared. Differentiate it first, you square that, right? Square this and then multiply by negative in front, and then multiply by the derivative of inside, which is x squared. That will make the integral become more complicated because it's become square. This thing square. So don't do that. We cannot use the substitution either, because the top is x squared and not x. So don't do that. Here's the deal. I would like to have an x here. Have an x to help us. So I'm going to write this integral as x times ln(x) over x times 1 plus ax squared dx. Because we can integrate this right now. X over 1 plus ax squared, because we have an x on the top. That will be much easier to integrate. So we're going to use integration by part. Be sure this a, I forgot to mention, if this a is equal to 0, you get what? Just ln(x) over 1, which is ln(x). The integral of ln(x) going from 0 to infinity pretty much just diverges. So be sure your a should be greater than 0. So I would like to start the DEI method. We are going to differentiate, integrate x over 1 plus ax squared, and then differentiate ln(x) over x. Right? So to differentiate ln(x) over x, you are going to square this. Let me do it here. Differentiate ln(x) over x. First you square this, and then x times the derivative of ln(x), which is 1 over x, and then minus ln(x) multiplied by 1, right? The derivative of x is 1. So far you will get 1 minus ln(x) over x squared here. And then we are going to integrate this x over 1 plus ax squared. We are going to use our substitution. Let u is equal to 1 plus ax squared, and then du will be equal to 2a dx, right? 2ax dx. On the top, we need a 2a. We need a 2a on the top to become our du. So multiply by dA and then divided by 1 over 2a to get back the original. So you will get 1 over 2a, and then the top you will get du. 1 multiplied by du. So this one, it becomes u, right? So far you get 1 over 2a. Integrate 1 over u, you get ln absolute value of the. But let me just forget about the absolute value, because the inside is 1 plus ax squared, right? 1 plus a squared, we want a is greater than 0, so the inside is always gonna be positive, right? So you are going to get this. This time that is the first part of the answers, right? this time this, which is 1/2a, put a constant in front, and then ln(x) over x multiplied by ln of 1 plus ax squared. Going from 0 to, evaluating from 0 to infinity. And then this one you are going to get negative 1/2a times the integral of 1 minus ln x times our ln of 1 plus ax squared divided by x squared dx. So here's the deal. If we plug infinity to here, plug infinity, and the top is much bigger, much smaller than this x is much bigger than ln x times this thing. So when x goes to infinity, and this is way bigger than ln x times that, so you get first is just 0. And the second one, plus 0 into it, you will get an indeterminate form, you know, right? Indeterminate form, and that's really bad. Plus 0 into it, 0, and then so many things. So I'm going to use the limit at x approaches to 0 plus. Be sure it should be 0 plus, right? And then ln x times ln of 1 plus ax squared plus x. If we plus 0, you get 0, and then negative infinity, right? ln 0 plus is just negative infinity, and then ln plus 0, you get ln1, which is 0. You get 0 over 0. That's not okay. So it's our L'Hopital's rule. You get this thing is just divided by 1, right? Divided by 1 because derivative of x is just 1, so it doesn't matter. Divided by 1, so you get, use the chain rule, ln x multiplied by the derivative of 1 plus ax squared, and then differentiate inside, you get 2a, right? 2ax. And then we are going to add ln of 1 plus ax squared, and then divided by x, right? So if we plus 0 into it, 0 is still bad, right? 0, 0. I'm not going to do more work here because it will take a lot of time. It will take a lot of time in this video. So I'm going to tell you this is going to get, you are going to get 0 here. So do this by your own. It will be too crazy if I keep going. So here, this integral, I'm going to distribute the ln 1 plus ax squared. You get negative 1 over 2a, and then this time there you get ln of ax squared. Wow, sorry, 1 plus ax squared. This kind of ugly. Sorry, I don't have enough space. And then this time this become positive 1 over 2a times the integral of ln x times ln of 1 plus ax squared over x squared dx. So here's the deal. I'm going to use the Freyman technique once again. Freyman technique. It should be ln of 1 plus ax squared over x squared. And if this indefinite integral, if you type this integral on Wolfram alpha, it actually can be integrated in elementary functions. So, but this is an improper integral going from 0 to infinity. But however, we can still use the Freyman technique. Don't worry. We let I of a is equal to the integral of ln of 1 plus ax squared over x squared dx. So this integral, these two integrals will be converges. Don't worry. And why? You ask me why? Why I don't differentiate x times ln x and then differentiate x ln x and then integrate 1 over x times parentheses 1 plus ax squared in our DI method, because if we put an x times ln x here, you get, do the derivative in your head, you get 1 minus ln x, right? And then this one, your product will be divergence, I think. So I consider this ln x over x and not x times ln x to division. Sorry, my fault. And then we are going to use the Freyman technique here. I'm prime of a, and this one a can be equal to 0, because if a is equal to 0, you get ln1 which is 0 divided by entire thing, you just get 0. So a can be greater or equal to 0 this time. I'm prime of a, which is 1 over x squared in front, because it's a constant, and then multiply by the derivative of this. First you get 1 over that, and then differentiate x squared. X squared is just a constant in the a world so far. Put the x squared, and then this x squared and x squared, they cancel each other. And then we are going to integrate 1 over 1 plus ax squared. We can write this as 1 plus this a as our square root of a times x, and then square that. So this is just inverse tangent, right? First you get inverse tangent, 1 plus something square, and then inverse tangent of square root of ax. And then don't forget to divide by 1 over divided by square root of a. And then evaluating from 0 to infinity. To infinity, you get pi over 2, right? So far you get pi over 2 times square root of a. Then plus 0 is just 0, so you just get this. And then we are going to integrate both sides. I of a will be equal to, so we are going to integrate 1 over square root of a here, dA, and then we are going to multiply by pi over 2 later. So for integrate this, what it says a power of negative 1/2. And integrate this, first you add 1 to the power, you get a power of 1/2, and divided by a new power which is 2. And we can write this as 2 times square root of a. Let me just add a plus c. So you get pi over 2 times 2 times square root of a, which is pi times square root of a plus c. Don't forget about the constant, because the constant is not always gonna be 0. So I of a is equal to that, which is this. And then we are going to plug a is equal to 0 here, and then pi, which is entire, you get 0 plus c. And this one I mentioned it, it's just 0. So far you get a constant is 0. So therefore our I of a will be equal to pi times square root of a. Let me just put down the answers to this. So you get negative 1 over 2a times our pi times square root of a, right? And this one, let me just write the 1 over 2a here. And this one, this integral will be convergence as well. So you have a x squared, ax squared, and x squared. So I'm going to use the Freyman technique once again. Let I of a is equal to the integral of ln x times ln of 1 plus ax squared over x squared dx, going from 0 to infinity. And the differentiate both sides, you get I prime of a, you will get ln x over x is a constant, keep it. And this one you get 1 over that, and then x squared is just a constant. So far you get I prime of a is equal to ln x over 1 plus ax squared dx. Ooh, this is really cool, because you see this integral is just the I of a, this question. So you get this one ln x over ln x times this 1 plus ax squared. Let me just write it down. So I of a will be equal to that, but let me do more work here. And then square root of a over a, you get pretty much just get negative pi over 2 times square root of a plus 1 over 2a, and then you get ln x 1 plus a x squared, the x squared dx. However though, can we differentiate both sides right now? No, because we have a 1 over 2a. So I don't think we have a formula which says that the derivative of a constant of a function, because this in our a rule, a function type integral. I don't think so. So be sure the coefficients of the integral should be 1. So let me just write down as I of a plus pi over 2a, and then is equal to 1 over 2a times this integral right here. And then we are going to multiply by 2 times a on one side. You get 2 times a times I of a. And then this multiplied by 2a, you get pi times square root of a. Wow. You see a pi times square root of a once again. It's really, really cool. And then this is equal to the integral of this, right? Aha! We can use our Freyman technique here because we don't have functions here. We just get 1. Be sure when you use the Freyman technique, you need to get this should be equal to 1. If you differentiate both sides right now, you pretty much just get a 1 result, and just make the entire question entire answer just that's not great, you know. So be sure this coefficient should be 1 here, and then we can differentiate both sides. So differentiate this first, you get 2a, and then derivative of I of a, which is I prime of a. We are going to use the product rule, and then plus I of a times this. Differentiate it, you get 2, and then plus. And then we are going to differentiate square root of a. This differentiate of square root of something pretty much just 1 over 2 times square root of something. That's a really quick trick, which is pi over 2 times square root of a total. So this is just equal to that ln x over x squared multiplied by 1 plus a x squared, and then x squared dx, and then that x squared and that x squared, they just cancel each other out. So what is this now? It's just this, the original, which is I of a. Yes. So 2a times I prime of a plus 2ia I of a plus pi over 2 times square root of a, which is equal to I of a. So you pretty much just going to do the, look at this, I prime of a and I of a, and then some functions. You're going to use do the first order derivative linear equation, you know. So be sure it should be something derivative, and then the original y, right? dy dx, and this y, and then this is just x. Consider this x, this a is x. So for first, you're going to get 2a times I prime of a, then plus I of a, right? I of a, because you subtract I of a on one side, you just get 1 I of a here. And then put a negative. So put pi over 2 times square root of a on the right hand side, you will get negative pi over 2 times square root of a. However though, you see a 2a. Whenever you are going to do the first order of linear equation, you are going to get the coefficients of the dy dx is equal to 1. So over divided by 2a on one side, you get I prime of a is equal to plus plus our 1/2a times I of a is equal to negative pi/2 times, it should be 4, right? 2 times 2 is 4, and then a times square root of a, which is a power 3/2. Add the power. And then we're going to find the integrating factor. Integrating factor, look at the, consider this our x, right? This is our x. And then this is our y. It should be y, and this is our x. This thing is just our integrating factor, right? So integrating factor I of x. But originally we use the I as our integrating, right? So I would like to put an F here to show this integrating factor. It should be A, integrating factor of A, which is equal to, remember that formula, which is e power of the integral of the coefficients of I of A, which is 1/2 ADA, which is our e power of 1/2 times ln A, which is just square root of A. You just get a square root of A. That's 1/2 square root of A and the square root of A. They are really different. Really different. So be careful. And then multiply by square root of A on one side. You get square root of A times I prime of A plus 1/2A divided by A, right? Square root of A divided by A, which is just 1/2 square root of A here, times I of A. And then this one, negative pi/4. And then square root of A, right? Square root of A, which is A/1/2. And then you're going to subtract the power. Minus 3/2, which is, you get a negative 2/2, which is 1/A, right? You're still going to get a 1/A. Here, so far, just stay this. Just keep the A here. You see ln. I already see ln because 1/A, right? Integrating both sides. So far, you get this one is just square root of A times I of A. Prime is equal to negative 4/A, negative pi/4A. And integrate both sides with respect to A. You get square root of A times I prime of A is equal to negative 4 pi/4 times ln A here. Don't forget about the plus C because we are going to do the indefinite integral this time. And then multiply by, it should be divided by square root of A on one side. You get I of A is equal to negative pi times ln A/4 times square root of A plus C because this is not constant, just kill the C divided by A. Ooh, finally we can figure out what the constant is. This is equal to the original, which is ln x/1 plus ax squared. So be sure A should be greater than 0, so we can put 1 here. If A is equal to 1, you get L1, which is 0, and then you get 0, and then C divided by 1, which is C. And this one, dx, you get the integral of ln x/1 plus x squared dx going from 0 to infinity. And this is a famous result. You can check my other videos, which is equal to 0. So over I of A will be equal to negative pi times ln A/4 times square root of A. Yeah. But this is now final result. We are going to do this integral. What's original integral, which is ln x/1 plus 4x squared dx, which is just plus 4 into it, right? Plus 4 into it, which is negative pi times ln 4/4 times square root of 4. Here you get negative pi over, and then square root of 4, which is 2. You get a here, and the ln 4 we can simplify to ln 2 square, right? ln 2 and the square. You can write this as 2 times ln 2. Bring the square outside the ln, and then this 2 and a, they simplify to 1 over 4. So far, your answers will be equal to negative pi over 4 ln 2. This is really, really awesome, you know.